We're continuing to work on the sample problems from section 10.3, and the last problem we did was number 24, which was a combination problem. And so now we're moving on to problem 26, which also deals with combinations. And it says, how many different 5-member committees could be formed from the 100 U.S. senators? So again, this is a subset. Order does not matter. We wouldn't allow duplications, so a combination is appropriate. So we have combinations of 100 taken 5 at a time, since we want a subset of U.S. senators. And so I'm going to use the combinations on my calculator. I'm going to enter the 100, then go math, probability, combinations, and I want 5 members on the committee, and that gives me 7, 5, 2, 8, 7, 5, 20. So that's 75,287,520 possibilities. Okay, and one last one on the combination section. Selecting lottery entries. In a 739 lottery, you select 7 distinct numbers from the set 1 through 39, where order makes no difference. How many different ways can you make your selection? Okay, so order doesn't matter. We can't duplicate numbers, so combinations again would be appropriate. And so we have 39 numbers, and we're selecting 7. Okay, so let me go to the Smart View calculator on this one. Okay, I'm going to clear my last computation. Okay, so I have 39 numbers to choose from. I want to get combinations, so I go to math, probability, okay, and I want combinations, which is number 3, and I'm choosing 7 in this lottery. And so I'm going to press enter, and it looks like we're getting 15,380,937. $380,937. Okay, now come in the next section we have the more difficult problems, because you may use permutations, combinations, the fundamental counting principle, or other counting methods. So in this case you have to choose the correct process. And a couple of these, there may be actually more than one way that will yield the correct answer. So in 34 we're dealing with poker, and if you aren't that familiar with a deck of cards, I know they have a picture of the deck somewhere here in the textbook. Let me see if I can turn to it fairly quickly. And I also have decks of cards. If you'll email me and let me know, I have them in my garage right now. It's where I've packed up all my office stuff. Okay, I don't actually see the cards in here. But if you need a deck of cards to look at so you can tell what they're talking about. Here they're talking about having a 5-card hand that would contain only cards of a single suit. So let's just think about hearts. There are 13 hearts, and so we're concerned with how many ways we could get 5 hearts. And if we think about, not only do we have hearts, we have diamonds, clubs, and spades. So we have 4 suits. And for each one of these, we would get combinations of 13 taken 5 at a time. So because of the 4 suits, there are 4 times the combinations of 13 taken 5 at a time. So let's clear this again. Okay, so we want 4 times, and I'm going to put this in parentheses to emphasize. So we have 13 cards in each suit. We want to go to combinations, 3 combinations, and where poker hand has 5 cards. And so I'm saying 4 times that, I get 5,148. Okay, that's 34. Let's look at 36. In 36, we have radio stations in the United States have call letters that begin with K or W. Some have 3 call letters, such as WBZ in Boston, WLS in Chicago, and KGO in San Francisco. Assuming no repetition, how many 3-letter sets of call letters are possible? Count all possibilities, even though practically some may be inappropriate. Okay, so we're talking about call letters. So if we have 2 choices, either K or W. So 2 choices for the first one. Now, if we're using one of those 2, then when I go, we can't have repetition. So that means I've removed 1 letter from the alphabet, which has 6 letters. So that brings me down to 25. Once I choose one of those, I have 24 choices. So let's see, 50 times 24 would be 1,200. Notice you could also do this with permutations of 25 taken 2 at a time. That also will give you the 1,200. Okay, let's look at number 40. And it says a music class of 5 girls and 4 boys is having a recital. So we have 5 girls and 4 boys. So it's 9 children in all. If each member is to perform once, how many ways can the program be arranged in each of the following cases? All the girls must perform first. So we'd have those are all girls. And then these 4 would be boys. So how many ways can we write? Well, 5 times 4 times 3 times 2 times 1, that would be 5 factorial. 4 times 3 times 2 times 1 times 4 factorial. Let's see what we get. 5 factorial is 1,200 times 4 factorial. Okay, I got 2,880. Okay, in part B, a girl must perform first and a boy must perform last. So we have our nine places. So we have 5 choices for the girl that performs first and 4 choices for the boy that performs last. Now the remaining children, we had 9, we've removed 2, so we only have 7 left. 7 times 6 times 5 times 4 times 3 times 2 times 1. So we're going to have 20. I'm taking 5 times the 4 times 7 factorial. Okay, 20 times 7, I'm getting 100,800. For me, it helps to draw the picture of the what's going on. Alyssa and Doug will perform first and last respectively. So it's going to look very similar to the last one we did, except we only have one choice for the first and the last. These are going to be ones, and then we're going to have 6, 5, 4, 3, 2, 1. So we're just going to have 7 factorial this time, which is 5,040. Okay, in part D, the entire program will alternate between girls and boys. Let's go to a new page. So we have 7 choices. Whoops, not 7, there were 5 girls. Alright, so let me draw my boxes first. 3, 4, 5, 6, 7. So we have to go girl, boy, girl, boy, girl, boy, girl. 1, 2, 3, 4, 5, 6, 7. I need 2 more. Boy, girl. Okay, so we have 5 choices for the girl, 4 for the boy, then 4 for the girl, and 3 for the boy. So 3 for the girls, 2 for the boys, 2 for the girls, 1 and 1. So what we'll notice is every other one of these with the girls gives us 5 factorial. Every one of these with the boys gives us 4 factorial. So that's basically what we had in part A. So it's going to be again 2,880. Okay, and E, the first, fifth, and ninth performers must be girls. Okay, so we have our 9. The first, okay, so this is a girl. The fifth, only 4 girls to choose from, and the ninth must be girls. So that's 5 times 4 times 3. Now, we've removed 3 children from the 9, so that means the remaining spots can be filled by 6 times 5 times 4 times 3 times 2 times 1, which would be 6 factorial. So we're doing 20 times 3 would be 60 times 6 factorial, and I'm getting 43,200. Okay, we'll do one last problem, number 44. It's dividing people into groups, and it says, in how many ways could 15 people be divided